lagoon streams. The water stored in them is extracted through wells and pumped to the surface by using electric pumps of proper capacity. The pumps require a large amount of electricity, which has a high cost. In addition, it is desirable to reduce the consumption of fossil fuel in power company plants, and this is accomplished by taking advantage of the energy coming from the sun. This kind of power is called renewable or green energy. This not only saves money, but our planet benefits from having less air pollution. To convert the radiant energy from the sun into electrical energy, solar panels are used, which transform the light coming from our sun into electricity. A typical solar pump installation consists of an array of solar panels oriented in such a way that they can get a maximum of solar energy during the day. It is important that they are located where no shades from trees, buildings, elevated tanks, or other obstacles are present. The initial investment in the equipment is very small, considering the great benefits obtained. The components to be installed are the array of solar panels, which is also called a photovoltaic array. Normally, in an installation of this type, no connection to the power company grid nor batteries are required. A controller device is used to take full advantage of the energy delivered by the panels. A submerged pump is placed inside the well in such a way that it does not lose contact with the water and works as long as there is water in the well. Once in operation, maintenance costs are minimal, and the operation costs practically drop to zero. Systems of any size can be built as needed. The system must be designed taking into account the water available during the year, the volume of water required for the surface to be irrigated, an area free of shadows to install the panels. All these factors require a professional study in order to achieve the maximum efficiency at the lowest possible cost. The typical operation would be as follows. At sunrise, sunlight begins shining on the panels, and they begin to generate electricity. In small quantity at first, but it increases as the sun rays hit the panels at a more perpendicular angle as the day approaches noon. The submerged pump, which can be either a centrifugal or volumetric pump, is designed to operate at a lower pace when it gets less voltage and gradually increases the operating pace to its maximum rhythm at midday. In the evening, the speed of the pump decreases until it stops when the energy produced by the panels is not enough. The whole system adjusts itself during cloudy days, so the capacity of the pump is used in different degree depending on the sunlight available. This is basically the way a solar pump system works. I hope this video has been useful to you. Thanks for watching, and please subscribe to my channel.
Well, it stands for variable frequency drive. They are used for running an AC motor at variable speeds, or let them ramp up their speed to give them a smooth startup. Some people simply call them drives. They work by adjusting the frequency of the motor to adjust the RPMs. To do this, a VFD will actually convert the voltage twice. First, it converts our three-phase AC to DC. This is accomplished with diodes. Then it cleans the DC with a capacitor. Next, it will convert the DC to AC. This is accomplished with transistors acting as switches. Utilizing these switches is what allows the VFD to adjust the frequency that the VFD supplies to the motor. This in turn controls the speed of the motor. Now, I know this is a lot of information to take in. Let me compare the internal workings of the VFD with a simple plumbing system. First, let's look at the diodes that convert the AC to DC. This operates like a check valve in a water system. A check valve, like a diode with electricity, only allows water to flow in one direction. The capacitor acts as a water filter to keep everything clean and usable. The transistors act like valves. They turn the flow on and off when needed. This allows the VFD to adjust the frequency of the motor. Now that we have an understanding of how a VFD works, let's see what they're used for. One very common use in industry is to control the speed of a water pump in a water treatment facility. A water treatment plant typically has a constant flow of water coming into the plant. However, if the water demand exiting the plant is lower than the supply entering the plant, then the operator will need to slow down the supply. This is achieved by using a VFD on the AC motor. The operator can monitor water flow and manually adjust the VFD accordingly. Another great thing about VFDs is the fact that they can be controlled with a PLC. Using basic communication protocols that have been covered in previous videos, such as RS-232 and RS-485, PLCs can monitor and control motor speeds using the VFD. This helps make a process like water treatment that much easier and more efficient. This setup can be used in any situation that would benefit from automation. Let's look back at what we now know. VFD stands for Variable Frequency Drive. They are used for controlling the speed of an AC motor. They are also used for ramping up a motor for a smooth startup, or to prevent a heavy load from straining the motor on startup. This is accomplished by adjusting the frequency delivered to the motor. A setup of an AC to DC converter, then DC to AC converter. VFDs are used throughout industry. A common example is to regulate water flow entering a water treatment plant. VFDs allow the operator to control the flow of the pump manually or automatically with a PLC. There are many different brands and features available. If you're looking at using a VFD, just be sure to do your research. I hope this video has helped you get a feel for VFDs. They really can make any automation or industrial process operate more smoothly. Make sure that you head over to realparts.com to find even more training material for all of your PLC programming needs.